Okay, so I haven't made a video in a while, so let's just see how this goes. This first lesson is about simplifying radicals, but you're going to have to think back and remember in probably, I don't know, 5th or 6th grade that you guys did prime factorization. And prime factorization was when you took a number and got it down to all prime numbers. Remember, prime numbers are a number that the only thing they're divisible by is 1 and their self. So if you think about some prime numbers, we have 2, 3, 5, 7, 11, 13, and they go on and on and on. Okay, but these are the numbers that we're really going to look at. And you'll hear me call these magic numbers. So back in 5th or 6th grade, you used these numbers to make a factor tree. So a factor tree may look like this. So if we look at the number 72. Now, 72, the first thing we're going to try is that first magic number, number 2. Can 72 be divided by 2? And it can, so we do 2 and 36. Now, we bring this 2 down, and we're still going to still see if 2 has any magic left. So 36 divided by 2 is 18. It did. And then 2, we bring that 2 down. We bring this 2 down. And 18 can still be divided by 2. 2 still had some magic there. Well, and we're going to bring these down. It doesn't want to work with me. That's our, so 2, 2, 2. Can 9 be divided by 2? Well, no, it can't. So 2 is out of its magic. We're going to go to the next number, which is 3, and 9 divided by 3 is 3. Now, I want you to look at these, and every single line, okay, on this has got to be equal to 72. Okay, so there's 72. 2 times 36, 72. 2 times 2 times 18, 72. 2 times 2 times 2 times 9, 72. 2 times 2 times 2 times 3 times 3, 72. And if you notice there at the bottom, these are all prime numbers, okay? And so that is the prime factorization tree. And I know you might do it different ways, but I think this is the best way for simplifying radicals. So if we were going to simplify, if this was a radical, so a radical is a square root sign or cubed root or whatever. So if this was a radical, 72, we would do the same thing. And when we got down here, we'd have 2 times 2 times 2 times 3 times 3. So simplifying radicals is simply taking all the pairs out. Okay, so I have one pair of 2s. It comes out of the house on a date. I have a pair of 3s. That pair of 3s comes out of the house on a date. There's no pair to that 2, so he stays home. And now 2 times 3 is 6. So 6 square root of 2. And that is how you simplify a radical. So, next example. Let's do the square root of 75. All right, so think about the factor tree. Can 75 be divided by 2? No, it cannot. So let's try 3. Can 75 be divided by 3? Yes. And I get 25. I bring this 3 down. Now, can 25 be divided by 3? No, it can't. So we move on to the next one. 5. Can 25 be divided by 5? Yes, it can. If I check that 3 times 5 times 5, I'm getting 75. So remember, this is still all underneath this radical sign. So this pair of 5s comes out of the house. 3 doesn't have a pair, it stays home. Example 3. Let's do the square root of 8. Can 8 be divided by 2? Yes, it can. 2 times 4. Can 4 be divided by 2? Yes, it can. So the prime factorization of 8 is 2 times 2 times 2. A pair of 2s comes out of the house on a date. That 2 stays home. And that is it for this video. We will work on some of these tomorrow, and I'll have to show you a little bit more. Okay? So, see you tomorrow.